And away we go with your review video for exam 3. Exam 3 will be very similar to the previous exams. There's 20 multiple choice, about 7 or 8 short answer, and 3 definitions from the third vocabulary list that you'll need to complete. So let's dive in. Um, Looking at the midstream industry, one of the big picture elements is it differs a little bit between gas and oil, and that's because, relatively speaking, almost all natural gas in the United States is moved by pipeline. It's just not economical to move it by other means. Whereas for oil and the refined products, they do move some of that around by other than the pipelines. You can see a lot of it goes by barge, a little bit of it goes by rail, and some by truck. Why did rail happen? So we talked about in class that rail spiked up quite a bit in 2014, and it wasn't because it was suddenly cheaper, because this shows you, remember we worked this problem in class um, to show you how it was considerably more expensive to always to ship by rail than by pipeline, and it wasn't because rail suddenly became safer. This is a picture of an accident that was taken in the 2015-ish time frame when they actually were using quote unquote new rail cars that were supposed to be very safe to transport oil. So go back and remember what was happening in the world in 2014 and why that drove the rail usage up. We talked about that in class. Whoops, sorry. Then we talked about the fact that our consumption of gas varies quite a bit out through the course of the year, whereas the production of gas does not. So all that gas has to go somewhere, and that's unlike crude, where refining tends to be relatively constant. And so we talked about natural gas storage and the various ways that companies can respond to try to meet demands on particularly hot or particularly cold days. And then be sure that you're comfortable with the differences between base gas and working gas. You're not going to need to know any of the companies. You are going to need to remember what a master limited partnership, MLP, does and why it is good for the midstream industry. Again, you're not going to need to remember anything about any of the particular companies or players. There's going to be a question or two on the LNG market. You're going to want to know, when does exporting make sense and what countries do so. You don't have to have them all memorized. The main thing is to know that Qatar is the biggest in the world, and then um, Australia is coming on, and the United States is coming on, but the main thing is Qatar. And then why do countries import LNG? And again, knowing that South Korea and Japan are the biggest current importers of liquefied natural gas, again, through this time frame, um, would be a good thing to know for the exam. We went through this fairly quickly, but remember that the liquefaction process is the expensive process. These are called trains, and they cost several $billion to build. Shipping is expensive, but not horrible. Storage, not too bad. And the regasification is surprisingly inexpensive compared to how it is expensive it is to um, liquefy it. Because of that, um, com companies like to sign a lot of long-term contracts because they have to put all this money into developing an LNG export facility. That trend is not in their favor. In other words, people are eschewing more of the long-term contracts, but that is their preferred way to make things happen. And so remember that the midstream industry has a big impact on the E&P market. We spent a lot of time in our class discussion about the midstream market, pointing out how it is impacting things in the Permian. This is the price difference between WTI Permian versus WTI in Cushing. And so this is a zero price difference. And all of this shows that during this period in 2018 and into 2019, that Permian producers were getting a whole lot less for their oil than other producers who were getting it to Cushing. In other words, fuel bought at Cushing was a lot more expensive than fuel put into the pipeline in the Permian Basin. Why is that? And then also make sure you remember why that this spread is going away. Moving on to the downstream industry, we want to keep the big picture in mind about the downstream. And these are the people that actually purchase the product. In other words, they buy particularly the crude oil. Obviously, the natural gas is just pushed on to the end consumer. So make sure you're familiar with crack spread. Also, I do want you to know that even though there is refining capacity all over the United States, the vast majority of the refining capacity, I shouldn't say the vast majority, 44% is located on the Gulf Coast, which is way more than in any other region. Don't need to know what the company names are or how they have gone together, but I do want you to understand several key things about the refining process. Number one, that the distillation is the first stop, and this is where you get your a lot of your high value products will separate just by virtue of the distillation. Then you have the cracking and the coking processes, and this is taking things out of the distillation process that's not gasoline and putting it through additional processes to try to produce more high value products, which would be the gasoline and then to a lesser extent the middle distillates. And so this is key about refining. The less equipment the refinery has, the less it's going to be able to beat up on the lower quality fuel. And that has two effects. Well, one effect, the high expense stuff, I should say, is where you're going to generate more gasoline. These are the high value products. Jet fuel and diesel are called the middle distillates, and they have a lower value. And then this is the heavy stuff like asphalt and fuel oil that there's not as much value in. And we're going to see this concept come up again in some other slides. So all refineries aren't equal, meaning that they have not all made the same investment in what equipment is there. And that's why people just don't want all the WTI that they can get their hands on, because WTI is a very light, sweet mix. And some of these refineries have spent a lot of money being able to handle a heavier mix of oil. Were they to buy all light sweet, they would basically be ignoring a lot of their capital improvements. They want to buy that heavier oil, which they get cheaper because they have the capacity to refine it. So not all refineries are equal, and remember, not all crude is equal. Condensate, which you don't see much of, but you put that through an atmospheric distillation tower and you get a lot of gasoline. Then you come around to light low sulfur, which is a long way of saying light sweet crude, and you can see you get proportionally more gasoline. And then as you go to light sour and heavy sour, you get less gasoline, typically more middle distillates, and more of the heavy stuff. And again, those concepts are going to be important for the exam. As far as the physics of how it works is, you put the product into the distillation tower, and it rises warmer down here, cooler at the top, and the heavier it is, the lower the temperature, which would, I should say, the higher the temperature, that it will go from vapor to liquid, and it will be separated out of the distillation tower. So the heavy stuff comes out at the bottom where it's heavier, and the gasoline, which is the higher value stuff, the lightest stuff, comes out at the top. It only translates from vapor into liquid at the top where it's cooler. So again, I want you to understand the physics. Hotter down here, lighter up, or I'm sorry, cooler up here. The heavy stuff goes to a liquid form at the higher temperatures as it just cools as it goes up. And so things literally drop out as they go up. I want you to understand that concept. Watch that if you have more questions. And I've really already talked about what we need to understand there. I want you to understand that refineries, not surprisingly, are a busy business. About 90% is their annual utilization rate, which makes complete sense given that they're very capital intense, and so you want to get your money back from those things. But there is more demand for gasoline in the summer, during the summer driving season, and in the winter for heating fuel. And so the spring and the fall is when they tend to schedule turnarounds, and that's where the utilization goes down, and you see that on that graph. Don't need to know anything about the specifics, but again, I want you to understand these key principles about the downstream industry. For the regulatory environment, there's really only a few key takeaways on the exam. And the first is that state law is what generally guides E&P operations. Issues like leasing, well spacing, pro-rationing, those are typically state issues. Federal issues are the ones that apply to environmental and safety regulations. So if you're familiar with that, you should be good to go on that particular. Our last topic is about renewable energy. So I want you to be familiar with the idea of power density. If you remember, cars at a given weight typically go a lot farther. I should say gasoline-powered cars go a lot farther than do electric-powered cars, and it's because of the issue of power density. And you can see that 1,000-pound battery has just as much energy as basically about 8 or 9 gallons of gas, which would be 50 pounds, and that's the power density. Because of this power density issue, long-range transportation is a very difficult market for electric vehicles. Believe it or not, they're even beginning to dabble in electric-powered airplanes, and this issue of to make it light enough to fly, you just can't operate the engines for very long, becomes a real range limitation. It's important to understand the concept of electrical variation during the day. The base load is what's on almost all the time. Typically, these are coal and nuclear power plants. And then intermediate and peaking, these are power plants that are brought on during the day and then brought back down. Natural gas is perfect for this because it comes up and down more quickly than either of the other sources. No questions about the grid or fuel sources. I want you to know that basically when we compare concentrated solar power versus photovoltaic solar, know their comparisons to each other. The idea of net metering is going to be very important, and I talked about that quite a bit in class. So make sure that you're familiar with what net metering is and the principles we talked about in class about what prices are reasonable to pay, given that the grid has to maintain. Electrical company has to maintain its grid. Nothing here in particular. The production tax credit, we'll talk about more on a later slide, but you just need to understand this is a big deal that drives wind. And this is why even if the wind company wasn't being paid by the electrical utility, it would still make money. So literally it could give its power away to the utility and still make 2.3 cents per kilowatt hour during the period that it receives the production tax credit. That's even why in the middle of the night, when electrical rates will go negative, the reason they'll go negative is because they know that wind will still sell the utility that rate, even if they have to literally pay the utility to take the electricity, because as long as it's less than 2.3 cents per kilowatt hour, it'll still make money. Know that Texas is the wind capital of the world, and know why. And we talked about this in class. Make sure you remember this rule of thumb that if you have, for example, a 2 megawatt turbine installation, that rule of thumb says multiply 2 times this rule of thumb of 1.2 to 2.2, so somewhere between 2.4 and $4.4 million would be a reasonable price to pay for a 2 megawatt turbine. So just remember that rule of thumb and you'll be in good shape. I talked about the subsidies quite a bit in class. So the big picture, what I want you to know is that the lion's share of subsidies for renewables come in terms of these tax credits for production. Whereas for fossil fuels, it's accounting issues of where you're being allowed to expense things, which has the effect of reducing your taxes in the near term. In terms of total volume, off this page, if you add it up, these are about 5 billion. These are about 4 billion for fossil fuels. And so what you see is, they're not that different in terms of total magnitude, but in terms of percentage of what's the actual electricity, there's a huge difference. Nothing about power protection and nothing about this. Okay, I'm going to stop and look at my notes because I want to make sure that you've got the major concepts in mind. Okay, I have reviewed my notes, and I guarantee you that I have pointed out every single test question on the exam to you. Again, I've talked about some really big picture things I want you to be aware of. I want you to know why there was such a price differential between oil in the Permian in the 2018, early 2019 timeframe, and why that differential is going away. I want you to understand part of the issue with wind and solar power is what's called intermittency, which is to say it produces when the weather's favorable and not when it doesn't. And because of that, it's hard to build that in as part of your base load, that you just can't count on it. And then there'll be a question there challenging your notion of what's a particularly good day for wind to provide a particularly large fraction of the energy that an area is going to use. Be familiar with make sure you're familiar with why not all refineries want to buy all the WTI light sweet crude they can get their hands on. Again, net metering and this concept of why the rates for net metering is so controversial. And I've talked the other issues in detail. Good luck on the exam.